on our YouTube channel, on the CTP Partnership YouTube channel. For online data declaration, please be aware that your name will be displayed on the list of participants. I'm gonna go through the agenda, but and I will give you some instructions regarding the Q&A session. So we will have Francesco Basile welcoming and doing the introduction, and then we will start with session 1. That is a session that is going to be moderated by Raquel Enoquera, where we're going to be discussing the emerging research and innovation challenges for offshore and energy technologies with the Professor Henry Jeffrey and Dr. Andrea Copin and the Dr. Ana Brito Emelo. Afterwards, we're going to have a Q&A session. In this Q&A session, it's the moment for the project coordinators to interact with our experts from session 1. So if the project coordinators want to pose a question, just raise your hand and then you can use your microphone to pose the question. Now for all the rest of the attendees, you can also interact by using the chat. You can ask questions using the chat. And after our Q&A session, we will go straight into the pitch session where the CETP projects in TRI2 related with this technology will have the opportunity to pitch your projects in 4 minutes of the time to pitch your project. And with this, I leave the floor to Francesco Basile to start the event. Francesco, the floor is yours.
Thank you, Irene, for the kind introduction. First, I want to express all my closed empathy to our Spanish colleague and all the Spanish country for the tragedy that they are now facing in Valencia. So I think with our work, we can contribute a little bit to maybe think that we are trying to do something for avoiding these things that are mainly related to climate to happen again. So I hope we will be with this mood and inside this workshop. And yeah, just a short introduction on our side, just to tell you that we are inside a Clean Energy Transition Partnership with the TRI2, the Transition Initiative 2, that is Enhanced Zero Emission Power Technologies. And we are now working in the framework of the knowledge community to increase all the aspects related to the cross-cutting issues and also the specific technology. The TRI2 is a very wide transition initiative because it's dealing with all the power production technology and of course technology solution with zero emission. And so we include bioenergy, concentrated solar power, photovoltaic, wind, ocean and offshore, as well as hybridization of technology and integration with storage solution. Of course, our transition initiative is also very linked to our stakeholder, that is the set plan implementation working group and ETIPS, where we usually consult for having our topic area well defined and aimed at contributing to the real development of the power production technologies. And we are now have launched in September, and it will be open till the 20th of November, the third call of our activities. And so we have already had one call, and our call was mainly giving the first call as giving a good share of different project portfolio technologies with the ocean energy, wind and offshore renewable accounting for almost the 50% of the project. And if we look at the project, we see also that especially the large projects related to TRI elevated that are the 2.1 in this case, it's mainly related to ocean and wind. So we are happy that beside our activity that we have already given on solar photovoltaic and concentrated solar power in last spring, we are now facing a period in which we will deal with offshore energy today, with all the aspects related to sustainability, to the perspective and the scenario and the sustainability. And in December, we will specifically have a meeting on wind. So I think we are in the conditions to contribute to also give you the opportunity to understand a little bit more about the whole scenario and the challenge that this technology is facing. We want also to thank you, our colleagues, if you can hear me, our colleagues from FACEIT that have give a lot of effort to organize this workshop, especially Irene, that you already know, and Ignacio Cruz, that is the one that is actually developing also the contact for the agenda and the concept of the thematic workshop. I have just to add that even in 2023, we have now approved last September 16 projects. And also in this case, we have a significant bunch of projects related to ocean energy, wind and offshore, even if a detailed analysis is not yet established. And we are also looking at, as I said since the beginning, the possibility of having integrated and co-located renewable energy, that I think it's a very good point for the ocean energy perspective. And that's all from my side, and I would really give you the floor to Rachele. Can you see my screen? No, maybe you didn't. Sorry. Maybe I can now. Can you see now? Yes. Okay. Okay.
No, Francesco, we were not seeing your screen.
Okay, so
Yeah.
maybe I can just show you. Can you see now?
No,
Okay.
no, I cannot see the presentation.
Can you see me in the screen?
I'm seeing you yourself, yes.
Okay. So let me just give you a brief. Sorry, I need to take out. Can you see the screen now, the presentation now?
No.
Yes. Okay, let me start again, maybe with a very short. Okay. So just briefly, reassuming the concept, we are in the Tier 2 enhanced zero emission power technology, facing all the technology related to power, as I say, bioenergy, concentrated solar power, photovoltaic and wind. And we, of course, develop also approach that are looking at hybridization and integration. We look to all the value chain and the possibility of developing improved performance, so high efficiency, low LCOE, optimize and decrease cost by coupling different technologies, but also increase scale up and lifetime of the technologies. We also look at sustainability, so the workshop today it's going in this direction also with some presentation. As I said, we have a good portfolio of technology in the 2022 calls. If you can see it, they cover all the area with the ocean, wind and offshore renewables accounting for almost the 50%. And we have a similar bunch of projects for the 2023 call that have been not yet fully analyzed, so I will not make this contribution. The ocean energy projects are also the one related to the high TRL projects, so we are really looking to hear from them what's the real solution, what's practical solution they are thinking to contribute to the development of this important technology. And that's, I would say, it's all from my side, and I will end the sharing of the screen and give the floor to Rachele Nocera, that together with me, it's in good faith, it is leading the TRI2. Rachele, the floor is yours.
Thanks a lot. Thanks, Francesco. I don't know if I'm already on the screen, but it doesn't matter. Hopefully you can hear me. Yes, I'm on screen as well. And thanks a lot for this kind of introduction and for framing today's webinar. But now we are entering really into the core of the discussion. The topic of today that we have proposed to our speakers is what are the grand challenges in offshore renewable energy, either technology challenges or environmental challenges. As you know, offshore renewable energy is going to increase its role in the energy mix in Europe for sure, but hopefully also in the rest of the world. Now we are going to have a kind of global overview of what are the challenges to hopefully achieve the targets in terms of installed capacity for marine energy or marine-based energy. It could be either wind, ocean energy, also floating PV, a lot of different renewable energy sources, but which have in common the fact that being in the marine environment, which indeed poses a number of challenges in terms of sustainability and not only technologies. We are going to deep dive into the topic with three international renowned speakers. First in line is Professor Henry Jeffrey. He is an expert on marine renewable energy. He teaches at the University of Edinburgh, and he also the co-chair of the joint program on ocean energy within the European Energy Research Alliance, one of the most prominent networks gathering together research labs and researchers in renewable energy technologies in Europe. Henry has an extensive experience in the energy sector with over 20 years, more or less, working in marine renewable energy, both in the academia, university, and industry. He started with really hands-on the fact because he was one of the key member of the project which is related to the world's first commercial grid-connected wave energy generator. So a first of a kind in Europe, I would say, but he is an expert in particular with the road mapping exercise. So designing roadmaps, strategies, action plans, and he contributed to design the UK roadmap for marine energy, which is an example for Europe, a kind of standpoint, but his international collaboration includes also Canada, the United States, Korea, and New Zealand, where he promoted this roadmap for marine energy and related research strategy. So thank you, Harry, for being with us. I'm going to introduce the other two panelists of today before leaving you the floor. And we have second in line in our agenda, Andrea Copping. Thanks, Andrea, for being connected with us from the Pacific Coast. So it should be morning coffee for you, I guess. So thanks to us for accepting our invitation. She is a senior researcher at the Pacific Northwest National Laboratory, one of the most important research organizations for renewable energy and in particular marine energy. She is by degree a blue water oceanographer, but she spent most of her professional career studying the interaction between human activities and the marine environment. Her current research interests focus on marine renewable energy and offshore wind development. But Andrea, she's also an expert within the International Energy Agency, the Technology Collaboration Program on Ocean Energy, which is a platform where researchers from the various countries involved in the IEA can share information about challenges, progress of renewable energy, and so on. So thanks, Andrea. And to complete the panel, we have Anna Britton-Melo, again, another important expert on marine renewable energy. She is the CEO of Wayback Offshore Renewables. She has over 20 years experience in the offshore renewable energy sector. She's now responsible also of the Secretariat of the Ocean TCP of the IEA that I mentioned before. And but in particular, she's the COO of Wayback, which is a private non-profit association devoted to the promotion and development of marine renewable energies and ocean engineering solutions. So they are really well placed to drive us in understanding what are the challenges ahead for the development of marine renewables. Without further ado, I leave the floor to Henry Jeffrey for the first presentation, which is focusing on the technology challenges in order to achieve this 300 gigawatt of goal at 2050, which is the targeted IEA goal for marine energy. Thanks, Jeffrey. The floor is yours.
Good afternoon, and thank you very much to the CETP for inviting me along to this webinar this afternoon, and also thank you, Raquel, for that kind introduction. I am Henry Jeffrey. I am based at the University of Edinburgh, where I lead the Policy and Innovation Group, where we work at the transition between innovation and policy development. As Raquel said, I also am joint chair of the ERA Joint Programme for Ocean Energy. But this afternoon, I'd like to speak to you within a third role I have, where I represent the UK government in the International Energy Agency Group for Ocean Energy, IEA OES. And so, to give a little bit of background to the presentation, in the autumn of last year, the Central IEA produced their net zero roadmap for 2050 about all the technologies that we will require globally in order to meet our net zero challenges. And what they identified there was that around 30% of the technologies that they require are still emerging. They're still going to require research and innovation in order to bring them to maturity. And wave and tidal is one of those technologies, and that's the focus of the IEA OES group. Although they cover salinity gradient and OTEC, their main focus is on wave and tidal. And so they then took it upon themselves to produce a complementary roadmap, a sort of a sister roadmap to the IEA's central one, to look at what the requirements were and what the opportunities were for the wave and tidal sector in order for those technologies to play their role in meeting the global technology 2050 targets. The first thing that they did was looked at what the size of the opportunity was for the wave and tidal sector. And so they did some market allocation modelling and said, okay, how much market share, depending on the cost reductions and performance improvements that these technologies have in the future, what could we achieve for global deployments by 2050? And they identified around 300 gigawatts of global deployments by 2050. So a very significant market share and contribution to net zero targets. They also analysed that there could be almost 700,000 direct jobs. So also, as well as meeting deployment targets, also very useful for helping countries meet their just transition with high quality jobs. And of course, associated with those high quality jobs came economic benefit, with around 340 billion of gross value added to economies around the world. For those of you unfamiliar with GVA, or gross value added, that's the sort of the economic benefit term that's used by treasuries around the world. And last but not least, they also indicated around 500 million tonnes of avoided carbon emissions. So very significant deployments, economic benefit, jobs and carbon reductions. So a very attractive picture overall for the wave and tidal sector. But what they also indicated, and were very, very clear about, was that none of this will happen without significant policy intervention. And so they identified that market pool mechanisms would be required in order to support the deployment of this technology in the same way that every other technology has required in order to make sure that it gains market share, improves its performance, reduces its costs. They also indicated that there will need to be significant technology push or technology innovation in order to drive down the cost as efficiently and effectively as possible, because that will reduce the overall cost of the market pool mechanism. They also indicated that there will need to be developments of infrastructure and supply chain in order to make sure that there is the ports and harbours and supply chain in place for the development, deployment and operations and maintenance of this technology. And then finally, that they would require improved regulation and legislation, making sure that that was timely and fit for purpose for the deployment of these technologies. So first of all, showing a very, very attractive overall price for the technology, but that price did not come on its own. It did require countries to take actions in order to make sure that they could enjoy and realise those very significant benefits. And it's those actions and sort of a little bit of context of them and the advice that the IEA are given that I'm going to take you through in the next sort of 10 or 15 minutes. So to begin with, looking at the technology push and market pool. So making sure that there's a market for the technology and making sure that there's innovation for that technology in order to make sure that you've got the right balance so the overall cost and benefit to your country is maximised. And so they did an analysis that looked at the different scenarios depending on how good you were at innovating the technology and how quickly you were able to drive down its cost and improve its performance, and what effect that would have on the overall cost of the market mechanism or auction mechanism that was used for the deployment of the technology. And the results are really striking. And these are global results, so they are very big numbers. Of course, they would be shared amongst all of the countries that would be engaging in this sector, but they showed that if you were innovating your technology around 15% cost reduction rate for each doubling of capacity, then this would have an overall price tag of around 130 billion between now and 2050, spread across all of the countries in the world engaged in the sector. However, if you were to be suboptimal in your innovation and driving your costs down, then that could raise by almost like a factor of 5 up to around 650 billion. And so clearly one of those tech numbers is clearly more attractive to treasuries of the world than others. They want for it to be at the 15%, not the 10. And so it really highlighted that in order for this technology to be a success and for countries to fully enjoy the benefits of it, then country-led innovation was really key in order to the success of this sector. And so the overall advice, and I've cut this straight from the roadmap, I won't read them word for word, is that having a market pool mechanism in place, whether that be an auction or a feed-in tariff led by individual countries, was essential for the deployment of the technology. But for that to be successful, then that needed to be paired with accelerated innovation to make sure that we had long-term cost reductions. And that could be in collaboration with other countries, because many of the technology challenges that this technology faces, whether you're in Europe or whether you're in Asia, whether you're in the Americas, will be extremely similar, if not identical. And so although the market mechanisms would have to be led by individual countries, the technology programs and their innovation programs had the opportunity to collaborate across countries in the same way that the CETP does. So moving then from the technology push in the market pool to the infrastructure and the supply chain. And so that infrastructure and supply chain, it covers the ports and harbours, the manufacturing space that's required, the laydown space for the assembly and the operations and maintenance. And they also did a case study of the number of ports that we would require globally. And what they've done is they've done an analysis of looking at how much fabrication space for manufacturing, and you can see, and the takeaway message to take from this slide is that although this ramps up significantly in the future, for the next around 10 years or so, we're in a reasonable position that we can use existing port and harbour infrastructure. And so this is not a bottleneck for the next 5 or 10 years, but it will become a bottleneck in the future unless countries are proactive in investing in their strategic infrastructure now to make sure that it's ready for in around 10 years in order to make sure that there is the capacity that this does not become a bottleneck for the wave and tidal sector in the future. Very similar to the manufacturing space, the laydown space that we will require for assembly and for the operations and maintenance in the future as these deployments ramp up. Again, there was reasonable capacity within ports and harbours in most countries, depending on your industrial heritage, to accommodate the requirements for around the next, let's say, 10 years. But in advance of that, there were very significant requirements that would require strategic investment. And that investment, they were indicating, would need to happen now in order to make sure that that infrastructure was ready in that 10-year period. Now, again, I've cut the quote straight from the report, but before I go into that, they gave an example that if we had a specialist port developed that had the capacity of around 300 megawatts a year installation and operations and maintenance capacity, then we'd require around 100 of those globally. So that gives you a feel of the size of the overall challenge. So it's not a bottleneck for the sector now, but it potentially would be a bottleneck in the future if investment is not made proactively to make sure that those ports and harbours are ready on time. And of course, some of those may not be new ports and harbours, some of them may be refurbishment, some of them may be repurposed, but some of them may be new. And that timeline associated with the development of a new port infrastructure does have a long timeline, and so that proactive approach is required now. And so that is the policy recommendation that's made there that you will see on the screen. A proactive approach to infrastructure deployment and development is required to make sure this is not a bottleneck in the future. And now the final point of the IEA's recommendations then relates to the consenting, the regulation and legislation that allows these devices to be deployed. And this is very similar whether you're dealing with offshore wind, wave or tidal. In fact, many of the renewables that we're dealing with is that the consenting and the acceleration of that consenting is really important. They did an analysis of the different consenting programs around the world for wave and tidal and felt that they all required acceleration, that needed to be done in a very still robust way, but they felt that there was a real opportunity to leverage the test sites that we have around the world that have acted as a testing ground for finding out what the implications are of this technology. They've looked at the different procedures that are put in place and found that the one consenting window committee, or the one-stop shop, was by far the most popular and the most efficient and effective with regulators around the world. They felt, because of the global nature of this industry, there was a huge opportunity for sharing data and transferring that information between regulators around the world. And because this was a sector that was not binary, that you were developing, tens of devices and then hundreds of devices over a reasonably long period of time, there was a real opportunity to use adaptive management in the development and consenting of this technology. So again, I'll give you the quote that they felt that there should be a regulatory framework in place that helps, not hinders, the deployment of this technology, but still has to be robust in its nature, making sure we were still being very thorough in the consenting, but using all those techniques that were mentioned on the previous slide, making sure that this was done in a timely way. And the IEA has done a lot of work in this, led by Dr. Andrea Popping, that will speak in the next session. So she'll perhaps tell you a little bit more about the work that the IEA are doing to help that consenting acceleration process. So just to round up, then the IEA have shown that there are very significant opportunities around the deployment levels that are available for this technology globally. The jobs and the economic benefits are very, very significant in meeting net zero and just transition targets, as well as the avoided carbon there. But it doesn't come without policy intervention. We do need to have market pool mechanisms led by individual countries. Innovation and technology push is really essential, and there's this opportunity for international collaboration. A proactive approach is required for infrastructure development, and that regulation and legislation to allow that consenting to be fit for purpose yet accelerated was really key. Now, I would normally end my presentation there, but given this highlighting about the importance of innovation, I wanted to highlight one other piece of work that was released just last week by the European Commission. So the European Commission last week released their new version of the Strategic Research and Innovation Agenda that goes into detail of those challenges for innovation that are so key to enabling this technology to go forward and move from innovation to commercialization. There is strong collaboration already between this SRIA and the CETP, so there's full knowledge of those topics. But just to give you a flavour of them, about those research and innovation priorities, they're mostly around the development of the technology and the devices themselves. That does, however, have to be underpinned by supporting subsystems and enabling technologies, as well as the collaboration and coordination to make sure that we're bringing those things together in the most efficient and effective way. You can look into the document and you will find more detail on each of those areas that I don't have time to go into today, but you can see each of those 6 high-level areas are broken down into individual areas where there will be more detail around the sort of the motivation on each of those areas, the types of challenges and the types of projects that have already happened over the past 4 years, and the main challenges that are remaining that need to be addressed in the future. And if you look at the document, you will find in each of those topic areas much more information on the context, their applicability, the actions that are required, and the expected outcomes. So I really ask you to look at that document for details of the technology and innovation challenges. So I am going to finish there, but hopefully that's given you a good overview from the International Energy Agency's perspective, both on the overall prize that's available to countries that engage in the wave and tidal sector, but also the policy requirements that are required in order to make sure that we take this technology from innovation to commercialization. So thank you very much for your attention, and I look forward to any questions that we have in the Q&A session. Thanks very much.
Thanks, Jeffrey, for this very comprehensive overview and for linking together the global overview to the more specific European approach, and in particular, what are the research and innovation priorities. Indeed, the challenges are manifold in order for the ocean energy and the marine energy to fly, but as CETP, we can provide a little contribution to the innovation. So we will have a pitch session with some of our projects, so we can deep dive a little bit more into that, and just to provide you with to give you a flavor of what we're working on in terms of innovation and technology development. But now I have to leave the floor to the second speaker, also because she woke up very early this morning to be with us. Andrea Copping, this is your turn to take the floor. And besides all this technology and market challenges, maybe you can help us understanding what are the sustainability challenges, because we are talking of installing energy farms, energy plants into the marine environment, which is a little bit, let's say, challenging also for the marine ecosystem. So thanks, floor is yours.
Thank you very much. And I appreciate tremendously the opportunity to be here today. Let me get my slides up here. and a wonderful lead-in from Jeffrey. Are you seeing my slides all right? Great. Okay.
Yes.
So thank you. I am Andrea Copping with Pacific Northwest National Laboratory in the U.S., but I'm also here today representing OES, Ocean Energy Systems Environmental. And what I want to talk about very briefly today is the importance of considering environmental effects of marine renewable energy. We're using that term, as Henry did, wave, tidal, a few other technologies. I want to talk about some strategies for understanding environmental effects and some of the up-to-date knowledge we have about those effects, and end with the question, what does environmental sustainability in this field look like? Okay, so I think we know there's a lot you've got to do to get these devices in the water. You've got to consider many things. You have to characterize your resource. Is there enough energy there? You need to think about where you're going to site your projects. You need to do some tank testing with your technologies. You have to think through your engineering design, how your moorings will be stable and efficient. Will your device survive at sea? How will you fabricate the first version of it? And how will you go on and manufacture many different devices? Financing, obviously, really important. Community engagement. But it's all sort of held together by this idea of looking at environmental effects or responsible development of the ocean. If you don't have that piece taken care of, it all comes crashing down. And this is because you can get everything else right, but if you don't gain regulatory permission, if no one lets you put it in the water, it really doesn't matter. So I want to talk about why we look at environmental effects. We're very clear on why we're doing this development offshore. Climate change mitigation, also providing secure, safe, low carbon energy, not only to the grid, but also for remote areas for energy justice. But this is in the early stages of development, deployment, and commercialization. And stakeholders and regulators have a lot of concerns. And their concerns are not unreasonable. These are new technologies going into new spaces in the ocean. But the ocean's already a busy space, so there's other users. And a lot of the populations of animals that we're worried about are already at risk from other activities, climate change, fishing, other human activities. And we do know, as Henry noted, that environmental concerns are continuing to slow consenting, or permitting as we often call it, worldwide. And this is due to uncertainty. We don't know what will happen. One of the key strategies we believe is collecting together and sharing information so that everybody has the same information base and we're able to move forward and build upon that and allay some of these concerns. This is what will be needed to accelerate the consenting processes. So a quick little ad here. OES Environmental is a task under the International Energy Agency's Ocean Energy Systems. We were established in 2010, so it's been a long time now. Our remit is to examine environmental effects of marine energy development so we can advance the industry in a responsible manner. This particular task is led by the U.S. The U.S. Department of Energy is on the lead, and my laboratory, Pacific Northwest National Laboratory, is tasked with implementing it. We work in 4-year phases. We have just finished our 4th phase that had 16 member countries, and there are their flags down there. And we're just starting a new 4-year phase, our 5th phase. So we're just still gathering the countries together right now. So in terms of environmental effects, we think in a framework of stressors and receptors. Stressors are the marine energy devices and the rest of the systems, the moorings, the cables that might cause stress, injury, death, damage to those receptors. And those receptors are the marine animals, they're the habitats, and also the ecosystem processes. And over this period of time, we have identified 7 priority research stressor receptor interactions, and those little icons on the right represent them, and as does the picture. And they include collision risk, that is animals running into blades of rotating, say, tidal turbines, effects of underwater noise on sensitive animals, effects of electromagnetic fields from cables on certain animals, the potential for changes in habitat, both the bottom, where there's a lot of stuff living, the benthos, and also in the water column, the pelagic zone. There are concerns from stakeholders that large animals might become entangled in mooring lines and cables. Frankly, we think this is a very, very low risk, but it's something that people feel strongly about. And also changes in oceanographic systems. What happens when will we change wave heights, circulation as we take energy out of the ocean? And the final one has to do with displacement. That is, if we have many devices out there, say in the paths of migratory animals, will it change their migratory routes? So we look at all these, we gather the information, we analyze it, and make sure it's readily available. Due to time today, I'm only going to talk very briefly about two of these, collision risk and underwater noise. So Henry mentioned that we are trying to work on ways to accelerate consenting. And we have done this through another framework we call risk retirement. And for us, this means that for certain interactions, all the risks don't need to be fully investigated. I need to note that right now we are working in a framework with information from about 1 to 6 devices in the water, because that's all there is. So that's all we can be very sure of. But for this with this information, we can rely on what's already been done, consented projects, research projects, other industries, so that if we can take those data and apply them elsewhere, we can move things forward a great deal faster. It's important to note that a retired risk can be brought back as more information becomes available. And of course, this can't replace any regulatory process. It's simply a way of trying to make information readily available and applicable. At the end of our 4th phase of OES Environmental, we have produced a major report. We just released it a month or so ago, the 2024 State of the Science Report. I have a QR code up there. I'll show it to you at the end again. It's a 300+ page report. It's a lot to it, 11 chapters, and I'm just going to touch on a couple of pieces of that. But I would encourage you to take a look. And if you don't want to read 308 pages or whatever it is, there is a shorter executive summary. We also have a series of what we call short science summaries, which are 1 page back and front, that really summarizes the information. So we hope we have information available sort of at all access levels. So I want to talk about just a couple of these, as I mentioned. I want to talk about collision risk of marine animals around turbines. And I'm talking about this one because this really is the hang-up for consenting tidal devices, especially moving to larger arrays. The worry is that the blades could hurt animals, particularly marine mammals, some fish, sea turtles, diving seabirds. And this risk remains high, or perceived to be high, because we don't have a lot of good information. We've never seen any collisions, but it's a very difficult environment to work in. It's very difficult to use We're getting a little feedback there. Very different. Hello? Am I still recording okay?
Yes, please go on, Andrea.
Yeah,
we muted the microphone for the
okay. Sorry.
attendee.
Okay, we have been trying very hard to get more information, more evidence, as it were, on these collisions. We haven't seen any to date, but they're difficult environments to work in. We are using underwater cameras more and more, and we use acoustic like sonar, but it is a tough place to work. It's often very cloudy. There are models that are being used actually for regulatory purposes right now. They're not extremely good, and they do not have enough data. And just to give you a little bit of a flavor of the sorts of things we're seeing, this is just a snap from a video. It's actually in our right off our lab in our bay in the Pacific. This is a harbor seal that is messing around a cross flow turbine, and this particular seal, or one of his friends, is there quite often. Even when the turbine's turning. However, when the turbine starts to turn with the tide, we see the fish and seabirds that are often around during slack tide leave the area. So that's a nice piece of evidence. This one here is a really nice still from video from Nova Innovations turbines up at Blue Sound in Scotland. And this particular grebe is very close to the turbine. Again, we see many marine mammals, fish, and diving seabirds around these turbines, but they all leave when the turbines start to rotate. So perhaps they understand the danger, or perhaps it's just too hard to fight the current. This last one is kind of hard to see, but this is a cross-flow turbine in a river in Alaska in the US. And that little silver streak off to the side is a salmon smolt that has just come through the turbine unhurt. Some of the animals coming through these turbines may be a little disoriented from the turbulence, but they do not appear to have any damage done. So this is the kind of evidence we're building bit by bit by bit, but it's very expensive and very difficult to get these kinds of pictures. Okay, I want to talk briefly about risks to marine animals from underwater noise. This is of concern because marine animals use sound underwater as we use sight or light on land. And they navigate, they communicate, etc. And it's already a noisy environment out there with shipping and all kinds of other noise. And the noise from turbines and wave energy converters, the generators, add to this noise. It's mostly marine mammals we worry about, but some fish also navigate by sound. These are usually quite low amplitude and also low frequency sounds. And happily, we have the IEC TC114 international specification for how to measure this sound in these very fast moving environments. And in the US, we have some regulatory standards for sound. And being able to apply this, we have looked at the sound of the existing turbines and WECs and decided that we can retire this risk for small numbers of devices because these sound levels are way below what any disturbance should be. Just to give you another little sense of this, if you look on the picture, the complicated thing on the left, the upper part, this is by frequency from about 1 hertz to about 1,000 kilohertz. And what you see in the upper part of the diagram is the range of frequencies over which these noise sources occur. Some are natural, some from the physics, from the biological animals in the ocean, but some of it is other kinds of noise, including marine renewable energy. And if you look in the bottom part of that picture, you see that there is some kind of marine animal listening, hearing across this whole range. So there's no good frequency we can work in. We simply have to manage what we have. On the right, I just want to bring to you one of the newer things we're looking at. Sound, of course, is a wave, but as it goes through the water, it disturbs particles, and we get this particle motion from the sound source. It dies away quite quickly to the source. And the reason we care about this is many kinds of fish that have lateral lines, this is how they perceive sound, is through these sound particles. This is not entered into the regulatory regime yet, but it's something we're keeping an eye on and really trying to understand so that it does not become a big issue for consenting. Okay, I just want to move on and give you some quick highlights of other parts of the State of the Science report, because it's not just about stressors and receptors. Social and economic effects of marine energy become very important, especially because they become entangled with environmental effects. If you go to a community and ask them what they care about, often when they talk about environmental effects, it's really about their use of the ocean and their use of the resources. We don't have a lot of research in this area, not very good methodologies. We have work that's been done in other areas like fisheries and supply chains, and much of that probably can be applied but has not yet been to marine energy. We know, as Henry pointed out, there are benefits to employment, economic development, but these come with social and economic costs as well. Everything from displacing other kinds of jobs, perhaps fisheries, also pressures on social systems, housing, schools, etc. And we know this is very tied up with understanding this, very tied up with early and often engagement with stakeholders. There's no substitute for going to the communities in which marine energy is likely to be deployed. Okay, we are also looking, I've been talking about this 1 to 6 devices, but we recognize that commercial size arrays are on the horizon, and we don't know how the knowledge we have now will scale to those larger arrays. So we've written a series of papers. The first one on scaling up to arrays has been published. 2 others are in press right now. The second deals with how do we bring the potential effects of marine energy into the ecosystem models that exist for fisheries and other activities. And the third is how do we look at marine energy in a cumulative effect with other human-caused pressures in the ocean. So that'll be work that's ongoing as the industry scales up and we get more direct information. The other place that we've sort of expanded into is the tropical and subtropical areas. Most of the effects information we have comes from temperate systems and largely northern hemisphere, but more and more tropical countries are entering into this, sometimes with different technologies. Will include OTEC, salinity gradients, etc. And tropical ecosystems work differently than temperate ecosystems. They have higher biodiversity, a lot of unique habitats like coral reefs and mangrove swamps. And we know in these countries, many of which are developing countries, that social acceptance is very tightly tied to ecological health. So we need to address these whole ecosystems and not just the stressor receptor processes we've been using. Okay, I want to end with talking just a little bit about environmental sustainability. How will we ensure that this industry is sustainable, is not causing long-term damage? Well, we really have to understand these potential risks, as I've mentioned them, to marine animals, habitats, and processes. And we need to know what part of a WEC or a turbine could be causing these risks so that we have the opportunity to redesign, redeploy, operate them differently. In order to do this, we have to have good post-installation monitoring data that demonstrates this risk or whether there's no risk. And the communication is really key. Being able to communicate this level of risk to regulators, there needs to be policy changes to consenting processes, but we need to have the information to prove to the regulators and stakeholders that what we believe is true. And finally, this communication and collaboration is really important, that we collect and analyze data and make it accessible using open data sites globally. Okay, I'm going to finish up here. I'm sitting up here, but of course it takes a village of researchers, a global village, my team at PNNL, and then the other 15 OES environmental representatives who are very hands-on. This is not just my lab doing this. All these people are very involved in all the work we do, and many hundreds more researchers, developers who have collaborated with us around the world. So I want to say thank you. There is the QR code for the State of the Science report, and I'd really love it if you'd take a look, because I think you'll find some useful information. It is on our TETHIS website, which many of you may be familiar with, where there's a real wealth of information. And that's it. Thank you. I look forward to your questions.
Thank you. Thank you, Andrea. Thank you for all the insights that you provided in your presentation. Indeed, it is a lot to think about when talking of marine energy and environmental impacts. Of course, there is a lot to study, a lot to investigate. There are many messages in your presentation. Maybe one takeaway for us, for the CETP community, is that we need data. So whatever our research project is, if it is at least at a pilot level, we would need to have a kind of monitoring component that would provide really useful data, even though at a pilot scale, not at the array scale, as you were mentioning, but it is would be a starting point. So this is something that we will try to embed in our course, maybe not immediately in the future, but thanks a lot. And I will pass the floor to the third speakers for today, Anna, Brito, and Melo, because we saw what are the threats for the marine environment, but it's not said that marine installation energy, renewable energy marine installation can be only harmful or potentially harmful for the marine environment. There could be a coexistence, isn't it so, Anna?
Hello.
Hi, we can hear you, yeah.
You can hear me? Okay, just an issue with sharing the screen.
Okay, take your time.
Okay.
Technology is always
It was
challenging.
working, and now it seems the button is not. Okay, let's start again. Share the screen. Share. It's not working.
Okay, maybe we can help the back office to support us and
Yes, let me try if I can share it.
Okay,
Yes.
now it's working.
Okay.
Okay.
It is? Okay. Okay.
Wonderful.
So thank you for the invitation. My name is Ana Brito Melo, and I work at WAVEC. I will be speaking about energy technologies in the marine environment, ensuring coexistence with marine life. In this presentation, I will give the perspective of WAVEC on this topic. So WAVEC has an active role in promoting the coexistence of marine energy projects and marine life. And as the development of marine energy accelerates, so does our responsibility to protect the ecosystems where these projects are operating. So we have been dedicated to ensuring that our initiatives prioritize marine environments, and I will bring examples of our projects. So I will address these topics: marine energy technologies and project life cycle, circular economy and sustainable designs, environmentally friendly technology designs, nature inclusive designs, marine spatial planning, multi-purpose and co-location, key innovations for sustainability based on artificial intelligence and digital twins. When we look to this topic, energy technologies in the marine environment and ensuring coexistence with marine life, there are two key points. On one hand, we have the growing global need for renewable energy and the role that marine energy can meet today's demand. And as we saw in the first presentation, with the energy transition, the potential for marine energy has become increasingly important. On the second presentation, we saw that the importance of protecting marine ecosystems, and we know that many species are already under stress from other human activities like shipping, fishing, and pollution, and therefore coexistence with marine life is very important for long-term sustainability, regulatory compliance, and social acceptance of marine energy projects. Other marine energy technologies, I'm speaking about, I'm including offshore wind, floating and fixed and floating, wave energy, tidal energy, so from the 8 difference between high and low tide, then tidal current energy, kinetic energy from fast flowing tidal currents, another type of current energy, ocean current energy associated with large circulations in the ocean driven by wind, temperature, and salinity difference. OTEC, making use of the temperature difference between the warm surface and the cold deep sea water. Salinity gradient, also known as osmotic energy, and floating solar. So these are the technologies in which WAVEC has been doing activities. And they are at different degrees of development and maturity. Some are already very advanced, like fixed offshore wind, and others are still at research and demonstration level, like floating offshore wind, tidal and wave energy. So mature technologies, they benefit from extensive research. So there are established mitigation practices and regulatory frameworks are in place. On the other hand, impacts from emerging technologies are still in the process of being understood. And I give here 2 examples of projects in which we have been involved to improve the current knowledge on environmental impacts, specifically for wave energy technologies. One was WES, European funded project dedicated to developing guidance for planning and consenting procedures on environmental risks and reducing environmental consenting uncertainty. And we have been collecting data from wave energy technology deployed in the Atlantic Portuguese coast, so wave roller. Second, in continuation of this project, we were involved in Safe Wave, we are still involved. So it's implementing also environmental monitoring activities to collect data. And in this case, we were collecting data from core power device also installed in Portuguese waters. With the aim to also to modeling cumulative impacts for future large-scale wave energy developments. Marine energy technologies, they should be designed with a life cycle approach. This means looking for development and geotechnical studies, fabrication and construction, installation, operation and maintenance, and commissioning. So in each, every phase is done in a way that supports the coexistence of energy projects and marine ecosystems. There are several policies. I listed here 3 key policies. So environmental impact assessments, the European Marine Strategy Framework Directive, and the Marine Spatial Planning Directive. So we aim to monitor and mitigate environmental impacts through the life cycle of the project. And if new risks to marine life emerge, we can suggest operational practices to be adjusted. And this requires that developers to work closely with all stakeholders. There are 2 complementary approaches that promote sustainability. So circular economy principles that help to extend the life of materials and components. And the LCA, so the life cycle assessment, that ensures that every phase of a marine energy project, so from the construction to the commissioning, this is designed to minimize the environmental footprint. When we apply the LCA during the design phase, this allows developers to choose their materials and process in a way that have a lower environmental impact. There are several examples like low toxicity paints, recyclable materials, environmentally friendly anti-fouling coatings. And here I included a list of projects in which WAVEC is coordinating the LCA task. Scarlet in Mission, it's about developing components. Nautical Sunrise in Bamboo for floating offshore, floating solar. Pivot Boy floating offshore wind. Mega Wave, Liftweg on wave energy. Plotech on OTEC. And Aqua Wind and EU scores on multi-use. Environmental friendly technologies, so designing with nature in mind. WAVEC is several ongoing studies on multidisciplinary and holistic design philosophy for marine energy devices. This means not only looking for performance, but also for the sustainability of the technologies. And we are looking for nature inclusive designs. This has been proposed by the industry for fixed offshore wind, and we are looking to the challenges to apply this for other devices. Heading innovation in moorings and foundations with elements like biohuts or fish hotels, and choosing also more sustainable materials like eco-concrete. So these are a few examples of initiatives where we are doing research. I also would like to give here the example of the Portuguese offshore wind bid that was recently announced for with a set of recommendations included in the bid to ensure that non-price factors are transparent using a concise set of criteria. So the idea is to incorporate environmental sustainability criteria through nature inclusive designs, promoting the circular economy, promoting also the coexistence with other sectors of the blue economy, such as offshore aquaculture, and considering social and territorial development criteria, promoting stakeholder engagement. So this is an example of initiative led by the government, taking into account long-term environmental and social outcomes. On maritime spatial planning, so addressing the increasing demand for maritime space from traditional and emerging sectors while preserving marine ecosystems, the European member states, they must develop national marine spatial plannings, defining their uses for the marine space, and following an ecosystem-based approach. So the idea is to reduce conflicts between sectors and search for synergies between different activities, increasing cooperation between countries, for instance, with the data sharing, identifying impacts at an early stage and opportunities for multi-use space. And finally, marine spatial planning is not static, and that can be adjusted based on ongoing monitoring of environmental impacts. And it's here where WAVEC plays a role. So doing monitoring work on the environmental impacts, and also looking for multi-use applications. I have here two examples: Aqua Wind, European funded project, in which a multi-purpose platform is being proposed for floating offshore wind and offshore aquaculture, using floating wind technology. We have been aiming to demonstrate the technical feasibility, the economic viability, and the environmental sustainability of this type of platforms. A different example is on co-location and is being conducted at the EU SCORES European funded project. It's a big consortium involving two demonstrations: offshore solar PV with a button fixed wind farm. This is being done in Belgium. And in Portugal, we have been looking for a wave energy array and floating wind farm from the perspective of sharing infrastructures. We have also been involved in the scope of two European funded projects on developing a European biofueling database, because we understood that the knowledge on this topic is not sufficiently transferred across the sectors, and it's a big problem for shared among all maritime sectors. So what we have been is including in this database all information on biofueling across geographies that are dispersed in many papers and reports. And so this database compiles all information available and gives an overview of biofueling in specific areas. So it can support site selection and support also development of biosecurity risk plans. Going to the end, we have been also involved in key innovations related with artificial intelligence and machine learning and digital twin of the ocean. And this started with ELIAD, which is a European funded project that gives us the opportunity to do research in this field. So machine learning is very important for monitoring and understanding the state of marine ecosystems, and gives the ability to process vast amounts of data. Also, we can improve the spatial resolution of bathymetric data, and have more accurate mapping of the seafloor, including identification of critical habitats. It can also be used to track the distribution and behavior of fish species where marine energy installations are being planned, and the energy developers, they can monitor fish populations and then adjust their operations. So there are many benefits of using machine learning in this studies. The digital twin that we have been developing with a big consortium include also complex environmental data and allow us to understand how the structure might affect the interactions. We can simulate scenarios over time and predict cumulative and long-term impacts. And in this way, it helps developers to test different alternative designs before the construction begins. It allows also to continuous monitor and with sensors and data collected from the actual site that can feed into the twin, and can be visualized and shared with stakeholders. So very helpful for stakeholder engagement. In continuation of this, this project is still running, but the data is being used, or it's aimed to be used by a new project in which we are involved, ClimaRest, which is about developing a digital toolbox for ecosystem restoration using data from Iliad. And so in conclusion, what I'd like to say is that marine energy technologies are a key component of clean energy transition. They do present challenges for marine life, but these challenges can be mitigated through innovation, regulation, and collaboration. And continuing to invest in research and engaging with stakeholders, we can ensure that marine energy contributes to a sustainable future, protecting the ocean ecosystems. And so these are my final message. Thank you.
Thanks, Anna. A lot also in your presentation, a lot more than what I'm able to process right now, but we will have time to go back on your presentation and on the various insights that you provided. I will take maybe one message, again, natural inclusive design and multi-use, because this is something, those are keywords that we introduced in our call for our project. So this is a suggestion to really design marine technologies which can coexist in the marine environment, or that can mitigate the impacts on the environment. So thanks a lot. Thanks. The slides, all your slides will be shared with the participants. But before opening to the floor to the questions, I will go back to Francesco Basile for a 30-second wrap up, if you wish.
Well, not easy wrap up from my side, just to acknowledge that I think our keynote speaker have really hit the points of looking at the challenge that we have in the offshore energy, and with the focus on ocean energy, of course, in the first presentation. And I think it's clear to all the speakers that we need to have a further push on innovation, and if we are waiting for the market pool and the regulation of the standardization of the technology, but we need really to look at the full value chain and at the full perspective of a technology, also looking at the site and the interaction with the environment and with the social aspects. This is a really complex task that I think we are more and more improving in our call module to take into account. And I'm sure project will start to give some contribution to that goals, and more goals will be faced in the next year. Let me conclude saying that it's really an important contribution today, what our guests have given to the audience, and I think it will be also useful for our future work. So I hope they will keep on let's say, advising us for improving our community knowledge and our perspective. Thank you, Rachele, so far.
Thanks, Francesco. Now we can open for the floor for a short round of question and answer to our speakers. You can use the chat panel. If you are a project, a CETP project, you can also open your microphone in case, and maybe Irene, if you can support me to control everything in case.
Sure, yes.
Thanks. Okay, I don't know if there is any question to our speakers, either from the audience or from the project.
I am not seeing any question to the speakers in the chat, and neither I cannot see any hands from our project coordinators.
Okay, so this is a very, very short round, and maybe we can spare some time.
There is one hand raised.
Okay, yes, now. Is it Johan? You can
hi.
speak.
Yeah, I just have a short question to Andrea Copping regarding environmental effects. It's about eDNA, environmental DNA analysis. If you think that will be important in the future, and if it's used a lot today, or if you have any comments regarding that technique.
Yeah, great question. eDNA is being used more and more. It's come from the sort of the terrestrial environment to the marine environment. We are starting to see it being used. It was originally just used very broadcast. For those of you that don't know, as opposed to running a DNA fingerprint on a specific piece of sample, you take bulk water or sediments and look at sort of who all is there, because every organism is shedding DNA all the time. And it's been very useful, for example, finding there are endangered species in an area. But more and more, we're starting to look at using it just to understand what the baseline of use of an area is and how it might change with climate change, etc. One of the problems with trying to understand environmental effects is you need to know what it looked like in the natural situation or the baseline situation, and then decide if changes are attributable to your technology or to something else. It is an inexpensive, really good way to go. So yeah, it's one of many tools that are being tried. So yes, if you work in that area, keep it up. It's a very, that and marine carbon dioxide removal, I see as the two sort of frontiers we're going to see more and more money available to, and sometimes we're looking for how we can use them.
Thanks, Andrea. I see there is a question in the chat. I will try to read it for you. It's a kind of a broad question. How can we ensure that we keep both enough protected areas but also exploit ocean energy? It seems like there are multiple hazards and not so many ways to mitigate them so far, especially about noise and electromagnetic fields. Is there any volunteer?
I can start on that one. Sure.
Yeah.
And I think Anna may have something to say around marine protected areas. This is why it is so vital to really understand what the level of emissions in the case of, say, noise and EMF are, so you understand the level of the problem. And I think we really have to be sure we are focusing our efforts on the real risks. There are many ideas out there of what could go wrong. Oh, whale sushi around turbines and so on. This is not a good thought. This is not a real risk. So I think we can do this. We need to look at marine protected areas, I think, at many tiers, those that are totally important to put aside for conservation with no touching. There are others where coexistence is very possible, but we need the data. And I think, Raquel, you said it really well after I talked. Every time a device goes in the water, we need to collect environmental data around it, because we have to have not just to determine what is going on, but really enough evidence to support that, be it legally or with communities, etc. So I believe it can be done, but I think we have to think hard about what protected areas mean, what is doable and what is not, and also really understand what those risks are.
Thank you, Andrea. But indeed, we have to say that concerning the protected areas, the same applies to, let's say, to the land protected areas. It's not an easy issue to tackle, indeed, how to ensure coexistence. But we are working on that. So apparently, Yeah, there are no other
especially
questions?
because we have now the natural restoration law that is very clear in protecting the sites and the area that are need to be even restored and renaturalized.
And I would like to note, we're very pleased. Europe is certainly leading the way ahead of North America anyway on this idea of preserving nature, but also this nature-based design, net positive. I admit to being somewhat skeptical. We have to be careful that when we say something is net positive, it really is. This is part of the problem with even putting carbon dioxide into the ocean and all these ideas of taking it out. We may be making things worse. So again, it comes back to monitoring, being sure that we don't have uncontrolled experiments, but rather we are collecting the data. But I really give kudos to the European Union for forcing these issues. They're going to be hard to meet, but we need to set those bright lines.
Thank you. So I don't see any hands, but I don't see hands in case, but I don't see either questions in the chat box. So I would open the floor to our projects. I would ask our speakers to stay if they can, because we are going to present very briefly a short pitch of 3 to 5 minutes maximum, our project portfolio regarding marine renewable energy technologies. I will invite our coordinators, project coordinators, or spokesperson to come on stage, and I will call them in the same order that I have in the agenda, just not to make mess. And the first on the list is Liselotte with the project Next Gen. It is a very technology project, but indeed it applies to wind or possibly wave energy. So it is important that they consider also sustainability, not only technology challenges. Liselotte, the floor is yours. One last recommendation for everybody. Please do not focus on the hard science behind your project. Just focus on the challenges and the way you want to address them. Thanks, Liselotte.
Thank you so much, and thank you for having us to present our project. Let me see if I can get the screen sharing going. There we go. You can see this, right? So,
yes.
Hi. So I am the project manager of this project named Demonstrating the Next Generation of Direct Drive Generators for Wind Power. I am also the CEO of the company Hagnesia Wind AB, and Hagnesia, the mother company, so to say, is developing a novel type of direct drive generators, which is very favorable for low speed, high torque applications, which is of course very relevant, not only for wind, but also for all sorts of marine energy, I would say, which is typically really high torques or high forces and really, really low speeds. So the impact that we're aiming for in this project and in Hagnesia by large is of course to help enable more competitive and sustainable wind power or renewable energy, really, if we also include ocean energy. And the background from this, I don't think I need to go too deep. Considering the audience, we need to build more renewable energy, wind power, ocean energy, all of it. The pace is picking up, but the acceleration is not enough. But we also see very important supply chain bottlenecks, not the least when it comes to the use of critical raw materials and also key components, both of which are sourced from a very limited number of countries. If we talk ocean energy, there's also a question of cost and price. It's simply very expensive to build things offshore. And we believe to have a solution to this in our technology, because as I said, we build a direct drive generator which is extremely compact and thus also efficient. So it's a new type of electrical topology, so to say. It's the same materials as in any other direct drive generator. It's the magnet, it's the copper, it's electrical steel sheets, but we arrange the materials in a different way, in a different topology, so it becomes extremely compact, which in turn also enables us to build it much more efficient, electrically efficient, with high efficiency. Which means that basically from the same raw material, and this includes magnet material, copper material, all of these critical raw materials that are so important for the green energy transition, from the same materials we can build 10 times the number of machines. We only use 10% of the material, which is, of course, could have a huge impact. And this is exactly what we want to validate and elaborate on in this project. Because I fully realize that it's quite a bold statement, which is exactly why we are so grateful to have this NextGen project, where we get the chance to really validate this and also accelerate the journey forward. So what we'll do in this project is that we have teamed up with what I would call the best of the best. It is DTU in Denmark, and it is Fraunhofer EVS. So what we will do in the project, the main goals, is to design and evaluate a larger design. So far we have worked with very small prototypes, and they have been proven experimentally, but now we want to size that up and see what sort of impact it would have on, say, a 10 megawatt machine, and to sort of understand the turbine impact at system level, and to find the pathway forward for how to prove this, how to validate it, and how to actually get this into market. And then also experimentally to build and test a megawatt-sized prototype to prove this. So this is what the project is all about, and we hope to be able to tell you more along the way within the project. So that's all from me, and if you are at all curious to learn more, please just reach out.
Thanks, Liselotte. Please take into consideration also this necessity, this need of having data, also at the prototype level. So yeah, whenever possible. Thanks a lot, and I will pass the floor to the next project in the list. I call on stage Johan Linden with the project More. Thanks.
Thank you.
Johan? Yes, there you are.
I'm here. If I can. Oops. I guess you can see the screen now.
Not yet.
Can you see the presentation? No?
No.
Oh, okay. What about now?
Okay, there you go.
There we go. Perfect. Thank you. So yeah, my name is Johan Lindén. I work at RISE in Sweden. I'm the project coordinator of the project called MORE, Next Generation Marine Materials for Resilient Offshore Renewable Energy Devices. And see here, if I can flip this one. Yeah. Okay. So let's see this one. So the challenges, specific challenges and needs that we focus on this project, quite technical one, is that offshore devices are constantly exposed to wear, corrosion, and fatigue, and particularly in wave energy converters. So current materials struggle with these combined stress factors, leading to high maintenance costs and short lifespans. And the existing material testing guidelines don't consider multi-degradation effects like combined triple corrosion and fatigue. And this results in unreliable predictions for material durability and equipment life cycle. So the solution in the MORE project is we will develop accurate, accelerated testing methods that account for complex and multi-degradation processes in marine environments. And we will create clear and reliable guidelines that would help the industry to choose materials that withstand the offshore conditions and lowering cost and increasing the lifespan. And our partners in this project, we're 9 in total. We have supply chain in Survey Group and Seal Engineering, companies based in Norway that are working on power and motion control in harsh offshore environments. And Seal Engineering are sealing experts for power takeoff rods and in very harsh conditions. We have technology developers in wave piston and core power ocean in Denmark and Sweden developing wave energy converters. And we have validation and impact in GC Node in Norway, a business-driven industry cluster with a lot of experience from the oil and gas industry that we can take into this new renewable energy sector. And we have VGA, an engineering company in Italy that's worked a lot and has experience in digital twin and hardware in the loop testing for wave energy converters. And of course, we have the research and innovation partners, RISE and SINTEF, that's the research institutes of Sweden and Norway. And we have the Norwegian University of Technology, NTNU in Trondheim, with a lot of experience in turbo corrosion and material science. So the more projects, we will listen to the offshore renewable energy sector. What do they need in terms of load levels, what components are affected, what materials is needed to test, and what do they want out of the testing and validation scheme. And we will have the fundamental research, especially at the university, looking at small-scale multi-degradation testing to gain fundamental understanding of what's happening to the materials and how to test them. And accelerate the testing at Research Institute at lab scale, looking more towards component and closer to the final product as well. So with Moore's approach, the offshore renewable energy sector will achieve a lower levelized cost of energy and reduce environmental impact and enhance European leadership in the transition to sustainable energy sources. So the Moore project will set new industry standards, providing a blueprint for resilient, cost-effective ocean renewable energy technology. So if you want to come in contact with us, you can either email me or call me, or we have a webpage, which is nice, and a LinkedIn account, or and also a YouTube channel where we post videos of the progress in the project. So thank you.
Thank you, Jon. I hope you are considering also sustainability in your guidelines, even though you're focusing on degradation of the materials, but sustainability would be an important aspect as well when working on new materials for the marine energy technology. Thanks a lot, and I will come on stage Katarina Bogström. The project is Sea Snake Plus. Katarina, please.
Yes.
We can hear you. Yeah.
Good.
Now,
can you see my screen?
Not yet.
Can you see my screen now?
Yes, coming.
So do you see it? Yes, good. So Sea Snake Plus is a project about that we're looking into the medium voltage cables. So we're not looking at a specific energy source, but more how to take the energy from like the wave until to the shore, maybe, and to the ones who needs the energy. So we're both is like two parallel questions. You might say it's both about the surface protection system and also the fiber optic based condition monitoring. So the challenge is that offshore energy has a demand for sustainable, durable, flexible, and cost-effective cables. Of course, you can use the big cables that you put on the lowest side in the ocean, or you can use these medium voltage cables that could either be on the surface or like down to 30 meters under the surface. They will be much more cost effective. But we do have some problems with these medium voltage cables. That one is fouling. On the upper picture, you actually see a cable, but there's a lot of fouling on it. So it's almost hard to see that there's a cable underneath. And the harsh environment will make all this fouling both because it's close to the sun, and also, well, that most lit. So you need a toxic-free surface protection somehow. The other thing is that the medium voltage cables, which is on the surface or just a bit below the surface, they move a lot more. And this harsh environment, we're not sure how they move. And we also want to know how much can they bend or stretch to be sustainable and durable. So here is, you can see just a small picture. This is a fish farm. I will just, we won't need to look at all of it, but here you can see that the whole fish farm thing is going underneath, and of course the cables will move with it. So here you see it underneath the surface, and it will be down like 10 meters under. And if you could just imagine, if there would be a lot of wind, this would be a lot of strain on the cables. Okay, so what we do, we need to do the surface protection. So we will develop a non-toxic paint. That's one thing. But since it's non-toxic, it doesn't take away everything. So we will also develop a cleaning robot. So we will do this on the cables. And then we also will develop smart cables with fiber optic, and we will do modeling and analysis and this fiber optic monitoring system. And of course, we will have to put this together and do lab testing and also field testing and validation. We have a pretty big consortium where we have companies that are doing this this paint, the non-toxic paint, and are trying that and testing it. We have the company that does the cleaning robot. Of course, we have the cable producers that produce cable that we can test everything on. And then we have the institutes and universities that do the modeling and the analysis. And then also the places that we have, that we can test this, both in a small, both in the lab test, but also when we do it near shore and down in the ocean, or down in the Mediterranean, to be more specific. So C6 Plus will reduce the environmental impact of the marine cables, or at least that's our goal, through digital modeling approaches and in real environmental conditions in different locations. The project will develop and verify smart cables for the marine market. So that was my pitch. And of course, you can contact us or me through my email. We do have a webpage, and we also have a LinkedIn account. Thank you.
Thank you, Katarina. Sounds really interesting. I see that there is something going on in Italy as well. I'm Italian, so I'm a little bit more involved into this. Thanks a lot. And I will come on stage Åsa Claesson for the project Smart Mooring. Not only cables, also mooring.
Yes, exactly. Not sure whether my video is on so you can see me, but thank you so much. So this project is working with data. We talked a lot about data already today. So data for better efficiency, better safety, and better reliability. So Smart Mooring is the name. So we are working on mooring components for ocean energy system. So what we do, or rather first, the consortium, we have Minesto and Copara Ocean that represents two, both the development and deployment of two ocean energy systems, tidal and wave. In this case, we have three partners that work with fiber optic sensing. So that gives you that our strategy is to integrate fiber optic sensing into the mooring components and use that data for various purposes. University Gustave Eiffel in France have a large-scale mechanical test infrastructure where we will validate the functions of the sensorized systems. So that was the wrong one. Here goes. So the main objective is to embed monitoring of strain, shape, and temperature in various mooring components. And that will enable data-driven design, data-driven strategies for in-operation health monitoring, and also potentially in the future, real-time optimizations of the operation to get out more energy from these systems. So that is the so the three sensor functions that we're introducing using fiber optics into these cables and components is strain, shape, and temperature. The challenges that we're looking at, of course, is you can place these sensors in many places in the various mooring components. So we're now trying to zoom into where it's most critical for the two cases we're working on. Fiber optics is very small, so one of the real benefits is that you can minimally intrusive. You can integrate them with a very small footprint in these components. So that is also the challenge that we're working on. And of course, one of the things that the companies want out of this is to be able to reduce the size of the mooring components with maintained reliability and function. So design strategies is a big part of the project, as is strategies for use the data for online health monitoring and planned maintenance in the future. So that is our main challenges we're working on. Very happy to discuss sensorizing components with partners that are online. We have, so here you see to the right, you see the two different use cases we're working on. On the top, you see the Minestos kite in the water. And of course, in that case, the mooring component is mainly this rope that goes down to the seabed. And the mooring components of the core power case is a bit more complex, I would say, and composite based. These are the contact details. I'm highlighted at the top. I'm the coordinator, so be happy to discuss with any of you. Thank you.
Thanks a lot, Elsa. There will be occasion to discuss and to group all the projects together to have a peer-to-peer exchange. And I see in your project that there are different ways to address sustainability, and reducing the size of the components is certainly one of that. But let's have a look at the ISOMOR project, and I will call Lian Lin on stage.
Yes, just a moment. You see my screen now?
Yes, we see the screen, not yet the presentation. If
yes.
you pass, yeah, to the
okay,
perfect.
Switch to now. Do you have the full screen? Huh?
Yes, indeed.
Yes. Yeah. Hello everyone. So I'm Yen Sao from Technical University of Denmark. I'm representing the ISOMOR project. Full name is Enhancing Shared Mooring System Design for Floating Offshore Wind Farms. So we're working on floating offshore winds, but it's a relatively smaller industry compared with bottom fixed offshore wind. But looking 20 or 25 years in the future, this industry will grow. So we're talking about the 15% of all offshore wind energy produced by the floating units. But currently, the cost is so high, is around 3 times that of fixed offshore wind. And if you look at the mooring system, the rough estimation of what we have seen in the recent project is around 20% of the capex. So if we want this 2050 target to be achieved, and then you estimate how many mooring lines we have, how long is the mooring line? If we put all the mooring lines together, and that would wrap our Earth about 2 times. So it's a lot of mooring lines to be produced. And then one would naturally ask, do we have a sufficient supply chain in the future if we all use steel materials? A possible game changer, as we see from recently from the industry, is that maybe the shared mooring, which means you don't connect all the mooring system direct to the seafloor, but you connect the floaters internally from by mooring system. We call it shelled mooring. On the other hand, we will propose to use more and more fiber ropes instead of steel materials. So hopefully this will reduce the use of mooring lines under the water and reduce some of the problems related to the hurt on animals and so on. So the specific need, we need a better understanding because this is a relatively new system. The system behavior is different. We need a better understanding. The standards we are following in the design is not necessarily good enough. So no one could say nowadays is good enough. So that's something we have to look into. We don't have enough good enough numerical tools to simulate the shelled mooring and together with nonlinear properties from the fiber ropes. We need more open access data for future validation if we want designers, operators to take this technology. And then we would like to also do something around the design procedures in the optimization. So altogether, we have a consortium of 11 partners with 6 universities, 1 research institute, 1 certification body, 2 suppliers, and 1 SME. So we are multidisciplinary project team coming from with a background in ocean engineering, offshore wind, material science, and expert doing model testing for materials and the tank test. So we want to provide the experimental and the simulation-based prototype demonstration for floating offshore wind farms and to elevate the TLR to approximately 5. Currently it's 3. And then increase the confidence of the end users to adopt this technology. So here is my contact. On the bottom right, we have the logos of all our partners. Yes, I think that's all from my side.
Thanks, Yan-Lin. So I hope our speakers are still with us just to see how we are tackling the innovation challenge and finding new ways to reduce the LCOE, the CapEx cost, the operational cost of the marine technology, and also addressing sustainability. So thanks, Yan-Lin. And I believe we have one more project, Stuart, and I would call Susan Wrigley. No, it is Alexander.
Yes, it's me. Hello,
Okay.
everybody. I am representing Susan here and the whole Stewart Consortium. So thank you for hosting this event. I have already learned a lot, and now I'm going to present you one more project. It's called Project Stewart, and this is an acronym for Science-Based, Environmentally Friendly New Layouts for Floating PV. And within Stewart, we are considering also inland applications of floating PV, but also offshore applications. And what we are planning to do, the project is going to start soon, and what we're planning to do is to investigate the effects of the current FPV designs. There are many different designs, as you probably know, and we want to investigate their effects on the respective ecosystems that they are being placed in. And based on that, we want to propose more environmentally friendly new concepts, adaptation concepts for floating PV based on a scientifically sound basis. And with this plan, we want to increase the sustainability of FPV systems, but also increase their performance and their affordability. So our first objective in order to achieve this goal is to establish a profound monitoring protocol to monitor the interactions between the PV systems and the respective ecosystems. I think the importance of monitoring has been underlined already in this event. And with this monitoring protocol, we want to test these systems on real sites. We have multiple sites, 3 of them inland on quarry lakes and alpine water reservoirs, and also one nearshore site, which you can see on this picture here. It's in the port of Brest and operated by Heliorec. Yes, and there we will test the effects or investigate the effects on the ecosystem, also especially on bird ecosystems due to their importance in general, and also especially their importance to floating PV due to bird droppings being a major factor for soiling problems and then hotspot formations on PV panels. We will also investigate economic aspects and legal aspects, and then ultimately want to create a guideline for sustainability-based design of floating PV systems. So our consortium consists of Solar Research Institute, the Fraunhofer Institute for Solar Energy Systems, where I also work. We have 3 universities on board, 1 university from Italy and 2 from Turkey. FPV industrial partners, INOC, BayWa, and Heliorec, and legal expertise in the form of the Italian law firm Tenucci and Partners. So we comprise a broad field of FPV knowledge to look at it from very different aspects. When it comes to specific needs within the CET partnership, we could always use further monitoring sites for FPV systems to increase our data set, and also regulatory counseling, as the regulations on floating PV are very different within the European Union from country to country. So concluding, within Stewart, we want to offer research-based solutions to enable FPV to become more sustainable and to become a feasible part of the offshore renewable energy landscape. So again, thank you very much. Here's my contact details. You can always, of course, reach out to me and my colleagues. Yeah, thank you.
Thank you, Alexander. We learned how important it is to have data on these innovative technologies for different purposes, of course, not only environmental monitoring, but also to provide data to the regulators in order to adapt and adjust the regulatory framework. So thanks for that, and we are looking forward to the results of your project. That said, we have one more project. It is called Infinity, and I call the coordinator Ola Billund.
Thank you very much. And find the presentation here. Hope it's in full screen now.
Yes, it is.
Thank you very much. So my name is Ola Billund from RISE, Research Institute of Sweden. So the full title of this project is Instant Force and Model Predictive Control for Ocean Energy Power Takeoff with High Fidelity. So what this is about is lifetime aware model predictive control algorithms that we will develop and test with the Infinity Wake Power Takeoff in a hardware in the loop test rig. So let's see if you can go to the next picture. So there are 2 main issues that we will address here. First of all, it's the control system, the control algorithms, where we will develop a model predictive control algorithm. These algorithms, they include in them a simplified model of the whole system, you can say, to make an accurate control possible. They have shown superior energy production in numerous studies, but they are difficult to implement in real-time systems, especially if the models are a little bit complex. As they are very efficient, if you optimize only on energy maximization, then you reduce the lifetime of the device. So what's new in this is also that we include damage models of critical mechanical components, so that we can also look at the operational expenditure in terms of maintenance cost, so that we can optimize not only on the maximizing the energy production, but also minimizing the levelized cost of energy. So more energy for the same cost. The second part of this is the ability to dry test a third scale model of the power takeoff system, the dry train. This is necessary. It's a possibility to debug debug the technology before we go to sea trials. This is also very demanding and costly for startups and technology developers, but we will use existing rigs or partners in the consortium to do this. So this is what the power takeoff system looks like. It's what you have down along the line, close to the bottom. The buoy itself, its materials, its design, and the materials used, and the fabrication of it is the subject of other projects, also CETP projects. We looked at, there's one project, WECHEL Plus, for example, that deals with that. So what we deal with here is only the power takeoff system and the critical mechanical components in that. So there's a lot of partners here doing different things. Yes. So this is a picture of the hardware in the loop test rig in Italy with the VGA, also developed in a former Horizon project. So this is you have actuators, and you can put the power takeoff device in here, and then you could have the newly developed MPC control algorithms and control systems into this, and all the monitoring equipment we use, and we can then test the rig, dry rig, in dry testing before commissioning in sea trials. So that was a very short pitch on this project. The project will start the 15th of December if everything goes well. So we are looking forward to start the project. Thank you.
Thanks, Ola. The need for dry testing was a need particularly stressed by the ocean energy community, exactly in order to reduce the cost of the prior testing before putting the technology into the sea. But I was impressed also by the ambitions you have in terms of reduction of the levelized cost of energy to 25% in 2050. I hope this matches the expectations, the market expectation, as Henry was illustrating before. So thanks a lot, Ola. Thanks, everybody. Thanks to all the projects for being in the time and for providing these very useful and interesting insights on their project. We don't have that many occasions to go deep into the projects, but I hope this is interesting also for our speakers, and they would like to stay connected with us in order to see what the progress are. Thanks again these speakers, thanks Henry, thanks Andrea, and thanks Anna. If you don't mind, we will stay in contact with you to move forward with the discussion on sustainability and technology challenges. And that said, I leave back the floor to Francesco for a final greeting, I would say.
Yes, just greetings and a little comment on the project we have seen so far. It's interesting to notice that most of them have also monitoring of the devices, which can be also useful for monitoring of the environment. As we have seen, it's very important. So we probably can suggest to of course, the project is not aimed at this, but maybe the impact of the technology improving the monitoring system can be also on the data that we can actually have on the environmental application of the technology itself. So I think most of the project can contribute to that, and this is an interesting point that we haven't yet probably realized reading the proposal. So we also learned something, and I want just to greetings everyone, and stay in really we are organizing new events for the wind community and for all the community related to the power production system. I think that in the next meeting we will have still all of us there in December describing this new project related to wind. And Ignacio Cruz from CEMAT and Irene Carlos from FEST will be with us together with me and Rachele from Ministry of University and Research. I will wait for your also participation in that occasion, and we all give you our greetings for this nice occasion to understand more about our project and about the scenario of the ocean energy. So thank you to all for being with us, and see you in the next occasion, and goodbye, good evening.